Okay, so welcome again. This is Remix IDE. Remix is a development environment. It's an online development environment, so you can find it at remix.ethereum.org. So it allows you to create smart contracts with Solidity. It allows you to compile those smart contracts, and it also allows you to deploy them, maybe testnet, maybe on a local blockchain. It provides you with a local blockchain that you can test with, and you can also use it to like compile to other testnets. So you get to explore all of those things along the way. But let's just get started. Like I said, this is Remix, and I just created a file. I named it learn dot. So just like other programming languages, it comes with its own. When you're naming or when you're storing a file, you have to add the extension. So for example, HTML is .html, CSS is .css, JavaScript is .js, Solidity is .sol, and this is how a basic, or how not basic, every Solidity contract, every Solidity smart contract should look like this. It should have this license identifier. So it's usually, this is like a standard SPDX license identifier. Now, what you put here is depending on the license you're using. So licensing just gives you, it just tells um both the compiler, both, although it's not really compiled, it's compiled in the bytecode, but it tells, since your code is going to be open source, it just tells everybody the license you're using, the kind of rights you're giving everybody to use your code, whether you're allowing everybody to use your code, or whether you're allowing just a set of people to use your code, or whether there's no right. Or so it just gives you a license. You add the license you're going to be using in your smart contract. So that is what that line is doing. You can change it to whatever you're going to be using. In this case, I'll just, let me just leave it at MIT standard. Now the next line, pragma solidity 0.8, it tells the compiler the version of solidity you're going to be using. Now this is important because um, the compiler is going to compile according to the version that you're using. If you don't specify exactly what you're going to be using, if you're trying to compile with another version of compiler, it's going to throw some errors, or some things will not just work because there has been an upgrade or something like that. So ensure you're putting the right version of Solidity that you're going to be writing. Now the next line is the contract itself. So every contract should have like the contract keyword there and the name of the contract. So in this case, this is student record. So I'm going to just be creating a very simple smart contract that records um, students information. So I'm going to be starting. So now, or I don't know if I mentioned in the other videos, but there are several data types in Solidity, including address, integers, string, booleans, enums, mapping, struct, and all of those things. Unlike other programming languages, Solidity is statically typed, meaning that you have to declare a variable before using it. If not, Solidity will not really be able to understand what you're doing. So, if, for example, if I'm going to be writing the address, if I'm going to be creating an address variable, I have to first of all write the keyword address for it to know that it is an address, and then I give it a name, student address. So yeah, I've created an empty keyword. But now it's not really empty because Solidity has a way of putting a default value in everything. So for this now, the default value will probably be um, a null address or a zero address. Just to see how it works, I'm going to add a keyword public to it. So what public does, public creates a getter function. It creates like, it makes this address to be visible on the blockchain so everybody can see it. Now I'm going to just compile. Don't worry, I'll come back here and I'm going to just deploy. And so I'm going to move this. So now if you click on it, you'll be able to see the address. So this is the default address that Solidity created for this variable. So I just wanted to explain that Solidity creates a default value for every key for every variable that you create. Okay, so I hope that is clear. So this is address. I'm just going to remove this keyword here, and I'm going to create a uint. Uint is on signed integer, so it's just basically like positive numbers. Like there's no minus, it's just positive numbers. So I would call this reg number. I'll create a boolean. Then this is just to say if the student is registered. So there are other data types. There is struct. So struct just allows you have a group of unrelated data types together. So you can have address, you can have boolean, you can have uint, all of those things. You can have it in one. So it just allows you um, collect a group of different data types together to use it. So this is struct. I'll just give it record, and I will say string. So I'm going to use the string keyword here, and I will say maybe class, that is student class. Let me just specify student class, school. So I'll add the string state. So let me just use something else. Maybe I'll use a uint again and just say school ID. I'm just using all of this to just explain the different data types. So I think the next one I'm going to be explaining is like the function. So function works like how a typical function works in JavaScript. So you have the function keyword, then you have the name of the function. So let me say this is to get student, So this is going to get um individual student data. Now I did mention that this variables that I declared outside of a function is actually a state variable. A state variable is a variable that can be seen, that is being stored in the blockchain. So this means that whatever I store here is going to be stored directly on the blockchain. There is also a local variable. A local variable means that it is stored maybe in a function, and it can only be accessed in that function. So outside that function, you cannot you will not be able to access that variable. So let me just create a so this is a function that gets the data of a student. So I can just say here, because I want to get dynamic data, I don't want to get static data. So I'm going to specify um I want the student to be able to put in their details themselves. So I'm going to say address. Well, let me just put it here. Student address. Then maybe I would add uint bag number. Then I'll add go register. Oh, I think I should just use this just to make it less complicated. So what I'm saying here is I'm just creating um, a function that collects data. So you're going to see that when I compile this, you will see it's going to create a space for you to put student address and reg number. Then there are different kinds of function. Like I used um, different kinds of function in the sense that it's based on visibility. So if I say public, it means that I want this function to be available on the blockchain. I want other contracts to be able to see it. I want it to be seen generally. And if I change this to private, it means that I want this function to just be visible in this contract. I don't want it to be visible anywhere else. If I change this to external, it means that I'm not going to use this function here, but I want it to be visible in other contracts and I want other people to be able to use it. And if I change it to internal, it means that I want to be able to use the function in this contract and I want other dependent or derived contracts to be able to use it. So it's not going to be visible to everybody. Only contracts that were derived in this contract and only this particular contract will be able to use it. I just wanted to explain the visibility types in Solidity. So there's also like the view and there's the pure. So both of them just allow you to see data, but the difference is that for view allows you to see, to be able to read data from the blockchain, but you're not going to be able to modify it. While pure doesn't allow you to read or modify, so that function is just going to be there. You'll not be able to like really do anything with it. Let me continue before I get distracted. So I'm going to store whatever I get here. I'm just going to store it back where I in the variables that I created. So I'm going to say student address will equal to whatever I get. Then I'm going to say reg number is going to be equal to whatever I get here. Okay, so let me just compile this and we'll see what we get. So I'll just move this a bit. Now in this compile, so let me explain this. This compile environment, it allows you to select which platform do you want to compile. So you can see Remix, you can see injected MetaMask, Hard Hat, Ganache, Foundry, all of these things. But this Remix VM is a virtual machine, so Remix kind of like runs a local blockchain for you to use. Then this contact address, you can see it provides you about 10, yeah, I think there are 10 or 20 addresses with Ether that you can use, because you cannot really run any transaction, you cannot really compile any smart contract, or you cannot run any transaction without Ethereum, like Ethers. So it just gives you free ones that you could just use. But remember, it's just for testing. You cannot actually use this anywhere. And then this supplies the gas limit, value. So I hope that in subsequent videos I will be able to give explanations that will cover all of this. I'll be able to give examples and show you how all of this will be used. But for now, let me just deploy and move ahead. So you can see that the function was created, and here it allows you to um, impute your students, like your address, and it allows you to impute your reg number. So I'm just going to go up and copy an address. So I'll just copy it and take it back to where it was. Then I'll just paste it. Then let me just say my reg number was 001. So you can see that it was successful. You can see that it was successful. So you can come down here to just read. So you just created a transaction, and you can see the gas that was used for this transaction. So you can see all the details here. Now you've created state variables, you've updated them with this function this get student function. So let me create another function that allows you to see the data. I'm going to change. I'm going to change this stuff. So I'll change this to set. Then leave this as get. I'm going to say public. I'm going to say view. Remember I said view allows you to read data, but you will not be able to modify it. Then I'm going to say returns. So I just want to return. Should I specify? I just want to return the data. Or there's no need to use returns here. But return will just display the data that you're trying to get. So here I'm just going to say student record and okay, it was reg number. It was reg number. So let me just deploy this. So I'll just deploy it. Okay, I'm not able to get anything because I did not return. So I'm going to return. Okay. I'm going to put them in two different functions. Put them in two different functions. Public view returns, then return reg number. So I'll change this to get address, get student address. Return an error. What's the error? Expected this, but got this. Okay, so I didn't put this, so I'm going to just put that. So this is going to return a uint. What's the issue here? Returns. I made a mistake. I didn't add this. So let me just deploy this and see if it works. Of course, it's going to work. Well, let's just do it. And I just deployed, and now you can see getting address and getting record. So this is the default value, like I said. So you can see that it's empty, and this is saying 0. So let me just copy an address, and here I'm going to put the address, then I'll just say 002, and I transact. So was it successful? Yeah, it was successful. So I'll click on get student address again, and you can see it has been updated. And I click on get student reg number, and you can see that it has been updated. So I don't know. So we just created a very simple smart contract. Like if you actually did this, you should be clapping for yourself, calling yourself senior developer. I'm joking, you're not a senior developer yet. But yeah, so there are other ones. There is this record. There is mapping as well. So mapping allows you to create key value. Something like a dictionary or maybe a hash map. Is that a good example? But it allows you to store data using a key value format where this is the key and this is the value. and let's say this is the name of the map. So anytime you save data, you're going to save it with a key that anytime you need the data, once you call that key, it's going to get all the values that you have there. So this value can be a struct, this value can be a string, it can be anything. Let me just create simple mapping, and I'll just put here address, and I can put here a unit or this struct that was created above. Then I give it a name, to the result. So this will allow me to create hundreds of student results, and anytime I want to get a particular student result, I just put in the address, and I'll be able to get this whole data of a particular address. Now I wish I could run that as well in this particular video, but I don't want it to get longer than this, so I guess I'll see you in the next one. So in the next video we'll actually be building maybe a more complex smart contract, maybe a staking smart contract, or maybe I don't know, I don't know. So I did mention this address I created will not be able to receive money unless I add the keyword payable. So now it's throwing an error, payable. So I have to add payable here as well. Payable. And the error is gone. So this payable allows you to receive ethers. The one I created without the keyword payable, it cannot receive ether. If you throw ether inside there, the money will not go anywhere. So the money will not be received. So what allows your address to receive money is this keyword payable. So I just wanted to put that out there. So thank you for watching. This is my first attempt of recording um, code. So let me know what you think. Do you think I should do this? I should keep doing this, or should I stop and continue talking? What do you want to learn? What Just tell me what you expect to see in the next video. So I'll call it a wrap. This is the final bye bye. Thank you for watching, and I'll see you in the next one. Bye.